Hello, if you are watching this video, you are ready to dive into Lesson 10 from our packet, Interpreting Graphs of Proportional Relationships. A little note I'd like you to write on the top as a reminder, our x value is representing our independent. Sorry, you can't read that. And our y value is representing our dependent. All right, so the two essential questions today I had to type in. Our first one is, what are 2 points that are always on a graph if two quantities are proportional? The other essential question was, how do we identify the unit rate? So hopefully by the end of this we can figure that out. Our problem here says Grandma's special chocolate chip recipe yields 4 dozen cookies and calls for 3 cups of flour. So the question we have to ask ourselves now is, what is our independent and what is our dependent event? So does cookies depend on flour, or does the amount of flour depend on how many cookies? I'm going to go with cookies. The number of cookies we can make is going to depend on how much flour we have. So that means that cookies are going to be our y value because they are dependent on how much flour, our x value. So now I'm going to come over here, and in the very first box it says create a table comparing the flour to cookies. So creating a table, our x value is on the left and our y value will be on the right. So I want to put flour, parentheses, cups, and then on the y side we put cookies. In parentheses, we're measuring that by a dozen. D-O-Z. Alright, so I have my units, and it says 4 dozen cookies will require 3 cups of flour. That's the only information they give me, but I want to make it proportional, so I'm going to continue. If I make 8 dozen cookies, I would need 6 cups of flour. Let's go one more and say, well, if I'm going to make 16, I'm going to double that. I'm going to double the 6 and say 12 cups of flour. I didn't really leave myself enough room. I guess I can do it over here. What is the unit rate of cookies? If I have y over x, what is the meaning of this in the context of the problem? So y over x, that's what I was going to put there, equals 4 to 3. We can leave that as a mixed number, improper fraction I guess it is, or we can write it as a mixed number. I prefer not a decimal in this situation because that would be a repeating decimal. So let's try to avoid repeating decimals if we can. Okay, so let's stick with one or the other here. Okay, so I'm probably going to stick with the 4/3 for my unit rate. Now I have to decide what it means in context to this problem. So what that means is I can make 1 1/3 dozen cookies with 1 cup of flour. Okay, I kind of skipped this problem over question here. It says, is the number of cookies proportional to the amount of flour used? Explain. Well, yes, I did make a proportional table here, so I know that my ratios are equal, but I'm going to say yes for every 3 cups of flour Grandma, Gma, can make 4 dozen cookies. So yes, it is a proportional relationship. Okay, moving down to the graph. We've been graphing a little bit in class. So you have a graph on your paper. I think it's a little better than the one I got here. So we always want to make our origin. Okay, make sure we know. I'm having trouble spotting mine, but it's 0, 0, right? And one of the biggest mistakes on our last quiz was making sure we had even intervals on our axes. So if I'm going to count up by ones, make sure that every dash mark is in fact 1. Okay, I went ahead and I had to blow it up. I was having trouble writing on here on that little graph. So I filled in my intervals. I went by ones, but I only wrote down every other number. So both axes have intervals of 1. Okay, so 1, 2, 3, 4, 5. And then on my X, I use flour, and I put in parentheses the unit that I was using. Same thing on my Y, I use cookies and put my unit in parentheses. Alright, so now I think I'm ready to graph. I just need a title. So Grandma's Cookies. Okay, now I'm ready to graph. Alright, so our first ordered pair was 3, 4. So over 3, up 4. 1, 2, 3, 4. I'm going to put a big old point there. The next one we wrote down was 6, 8. So over 6, up 7, 8. Another point there. And then the last one was 12. And then up 16. So another big point way up there. Alright, so like in our other graphs, we can connect these. That looks like a pretty good line. And if I had 0 cups of flour, I can make 0 dozen cookies. So 0, 0 is a part of our relationship. So looking at the next box, it says, does the graph show 2 quantities being proportional? Well, yes, it does. Okay, our reason. There is a straight line. And goes through the origin, which is 0, 0, just in case you didn't know. Okay, now I'm going to shift over and we got one more box to fill in. Okay, so last but certainly not least, we need to write an equation that represents this proportional relationship. So remember that our equation that we use is the y equals kx. Looking in the box above us, we should be able to find that our k was 4/3, right? So that's what I'm going to use here. So y equals 4/3 x. And if you wanted to spice it up with your other variables, we could say that C for cookies equals 4/3 F for flour. So I would take 4/3 times how much flour I have to figure out how many dozen cookies I could make. So one of those 2 equations would represent our proportional relationship. Okay, I feel like this was a really good review of everything. In this format, that we just used with the big table, this format is similar to what you'll see on your quiz. Okay, so there's good to know information. Okay, so similar to the quiz that we have scheduled for the end of this topic B. But I didn't really answer my essential questions on the top. So hopefully the next video that I have planned will help us with that. So stay tuned. Thanks for watching.